So there are new participants, so I want to revise it. So the first thing is that every instruction is divided into two parts. If it is not instruction, that complete area is now available for the data. No issues, no nothing, all bits, whether these are 32 bits, 64 bits, 120 bits, 128 bits, they all are available for the data. But if it is an instruction, instruction is assembly language command. If it is an instruction, then this area where the instruction is saved in register and in memory is divided into two parts. The division of these two parts is 5:3 ratio. So if it is 32 bits, the first thing, the 5 wala side is basically 20 bits and 3 wala side is 12 bits. So that 5 ratio side is actually opcode, means the actual instruction, the command, and if that command requires some sort of value, some sort of data, or the name of a register or anything, then that goes to operand part. All right. So LDM hash n. So hash n means that it is actually a value. This hash in assembly terms is called immediate, means it is no address, it is the value itself. So take this number n and put it in accumulator. Second one is LDD address. LDD means load direct, and whatever the content of your address in the memory will be loaded to the accumulator. LDI indirect, at the address given, the address of the data is present, not the data itself. All right, so when you go to this address, the content that you will find will not be the data, but the address of the data. And then from that address, you will fetch the data. So it is indirect. LDX means that we are now going to utilize the index register. Index register's content will be added to the address that is given. I told you that index register is used when we like to access consecutive memory location. It will be clear to you as soon as we start tracing, you would have a good idea of it. So index register's content is called offset, and this address over here is the base address. So what basically happens to this address, let's say it is LDX 50 and the content of index register is 5. So this 50 is called base address and that 5 in index register is called offset. They both will be added. The result would be 55. So data will be fetched from 55. LDR. Until now, LDM, LDD, LDI, LDX, they all were loading to the accumulator. But this LDR loads to the index register. Then we have got move. Move means moving the content of accumulator to the given register in the computer. In your syllabus, it would be mostly index register. So the content of the accumulator will be moved to the index register. Then we have got store. What store does is store takes the data from the accumulator and through the memory data register and the data bus, it takes it back to the memory and saves it there. All right. So LDD, LDI, LDM, LDR, LDX, they all are bringing in the data from the memory to the accumulator. Store is taking it back. So technically it is called write back. The data is written back to the memory. And if we are bringing in the data from the memory to accumulator, it is called read. The data is read to the accumulator or the microprocessor. Okay, so store is the only command which is taking the data from the accumulator back to the memory at the given address. Add. Now add has got two forms. Let's say your accumulator has got a value 5. You want to add the content of the address 60 in the memory to the accumulator's content. So what you will write, add 60. 60 is the address. So the content of the given address will be added to the content of the accumulator. And sometimes you just don't want to access the memory location for addition, rather you have got your own value. So immediate value, you can give immediate value by having this hash. So if your accumulator has got 5 and you want to add 3 to it, all you have to write is add hash 3. So that 3 will be added to the 5 and the result will also be stored in the accumulator. So add means addition. Similarly, we have got subtract. So what subtract would do? Subtract will subtract the content of the address in memory from the accumulator. Subtract the content of the given address from the accumulator. Or simply if you want to subtract the value by yourself, then you can give immediate value. So with hash. Then increase. What increase does? Increase is actually an instruction that increases the content. Content is always a number. In registers, the content is always a number. So that number, whatever the number in accumulator or index register, will be increased by 1. There is no exception to it. Every single value when you pass this instruction increase will only be increased by 1. Will only be increased by 1. So if you want to increase index register, so you will write INC-IX, increase index register. If you want to increase accumulator, then you will write INC-ACC. So ACC is accumulator. So increase requires you to give the name of the register, accumulator or the index register. So increase only increases index register and accumulator for your syllabus. Similarly, decrease. Decrease also decreases by 1. So if the content is 5, it will become 4. If the content is 3, it will become 2. All right. So you can decrease either the accumulator, the general purpose register, or the index register. So these are mathematical operations. You remember they said that there are groups of instructions. So we discussed data movement group, LDM, LDI, LDX, LDD, and LDR. LDM, LDI, LDX, LDD, they load to the accumulator, LDR loads to the index register. So this is data movement group along with store. Store takes the data from the accumulator back to the memory. So these 6 commands are data movement. Then we have got increase, add, increase, INC, ADD, add, and SUB sum. These 3 commands are actually arithmetic operations. All right. So let's see what other groups do we have. We have got jump. Jump means we know that computers' default working behavior is sequential. One instruction, then the next, then the next, then the next. All right. But sometimes you might want your computer to jump certain number of instructions or to a certain instruction. All right. So, and we know that these instructions are found in the memory with their addresses. Okay. So if you want your computer to jump to a particular instruction, you will have to give the address of that instruction. So let's say you have got instruction at 50, 51, 52, 53, and you want your, and at the moment 52 instruction is being executed. You want your computer to jump to 60. So 52 instruction would be like JMP 60. So instead of executing 53, 54, 55, 56, computer will directly jump to 60. So this is sometimes required. We will see how and when. And this jump instruction, what it does, it just jumps to the given address and starts execution of that particular instruction at that new address instead of going any in series. Then we have got comparison. Compare. Compare means compare. There are two types of comparison: address and what? The value itself. So let's say you want to compare the content of accumulator. Remember, always if it is not mentioned, it is for accumulator. All right. All the commands mostly are referring to the accumulator. It is written over here. All questions assume there is only one general purpose register called accumulator. All right. And the word ACC denotes accumulator. So you are comparing the content of accumulator with the content present at the given address. And sometimes you don't want to compare the content of the address, rather you want it to compare with the value itself. Let's say you want your computer to go 5 times. So every time you will be changing the data in accumulator, or your instructions will be changing the data in accumulator, and you would be checking that data against value 5 if it has become 5. It's like you want to move it on one by one 5 times. So this is like for next. In for next, what you write? For x is equal to 1 to 5. So similarly, you want this program to stop once the 5 cycles are completed, something like that. So you will be comparing it with the value. So आप उसको value से check कर रहे होंगे. All right. Now this is CMI. Compare in indirect way. Compare in indirect way. Indirect addressing, the address to be used is at the given address. Compare the content of accumulator with the content of this second address. So instead of, see, there are 3 forms of comparison, right? Compare with the address direct, compare with the value, or compare with the indirect address. So what will happen that the address that is given, we will reach out to that address. Over that particular address, we would have another address placed. We will take that address, go to that address, find the content, and then we will compare it with the accumulator. If it is direct, the address that is given, we will reach out to that address directly, take the content and compare it. If it is value, instead of going to any address, what we will do, we will just pick up that value and compare it with the accumulator. That's about it. So now what we will do with the comparison result. We are not concerned with comparison result like we are in high level languages. If it is less than, or if it is greater than, if it is less than or equal to, greater than or equal to, or if it is equal to, or if it is not equal to. So there are 6 types of comparison in high level languages, but for assembly language, we have got just 2 types of comparisons, whether it is equal to or if it is not equal to. All right. So let's say we have compared the content of accumulator with the address or with the content. Now, what will be the result? Result would be either it is equal to or if it is not equal to. In that case, there are 2 commands which are called jump if equal to, jump if not equal to. All right. So what basically happens, the idea in your syllabus is simple. And that idea is you compare 2 values. If the result is equal, you go to a certain command and start execution from that point onwards. And if it is not, then you go to another command and you start execution. So it is like if then else in assembly language. All right. So sometimes what we say, let's say if A is equal to 5, in this case, we will say if accumulator is equal to 5. If accumulator is equal to 5, go to instruction number 10. Otherwise, go to instruction number 13. That is how it works. So we will compare after the comparison, we will jump. Jump if the comparison is equal, jump if the comparison is not equal. So this is called JPE, jump if equal address. Jump to this address if the result of comparison was equal. Follow the comparison instruction, jump to this address if the comparison was true, the result was equal. Jump if not equal. follow the compare instructions, jump to this particular address. If the comparison result was false, means not equal. All right. Now we have got in, out, and end. In means whenever you press a key over the keyboard, the ASCII code of that particular key, the ASCII code of that particular key will be saved in accumulator. And we don't need any operand in it. We just write in. So let's say you have pressed A, capital A. So the content of the accumulator will become 65 in binary. All right. Similarly, this is actually from keyboard to ASCII value in accumulator. So whatever the key that you press over the keyboard, accumulator would have the ASCII code of that particular key in accumulator. That is with in. So it says that key in a character and store its ASCII value in accumulator. Out. Now what out would do, whatever the ASCII value that is in the accumulator, the shape of that value corresponding to that value in accumulator will be shown over the screen. So that is out, inverse. So if it is 65 in accumulator, what you will look at the screen, what you will see over the screen, A. All right. So when you press a key, its ASCII code goes to the accumulator, and if it is in command or in instruction, if it is out instruction, then whatever the number that is placed in accumulator will be treated as the ASCII key, and its corresponding shape or the character will appear over the screen. Output to the screen, character whose ASCII value is stored in accumulator. And then we have got end. End means the command which tells the computer this program is now ended. It is no more being executed, no requirement to go any further. That's about it. Technically, we call it giving the control back to the operating system. Otherwise, what do we call it? The program is ended, program is finished. But technically, what do we call it? Technically, we call it that we have given the control back to the operating system. Now the last thing. The last thing is simple. Let's say I want to load from address 65. All right, so this is an address. I might write this is in denary form. I may write it in binary form. All right, so I will write LDD B 1, 2, 4, 8, 16, 32, 64, 128. So this is the same, but the answer is, sorry, but the address is now in binary form. All right. And if it is hexa, in that case, we use and sign, I believe. So this would be 4, 1. So these all three commands are the same. Computer will accept them. Okay. So this is denary, this is binary form, and this is hexa form. All right. So get the idea. So this address here, this value here, they might be in denary form, they might be in binary form, they might be in hexa form. So you would have to mind it better. ठीक है? So exam में ये तीनों में से किसी भी form में आ सकता है. Exception कोई नहीं है. But if you like to save the value itself, in that case, let's say you want to save 5. So in that case, आप लिखेंगे LDM5. So this is denary. लेकिन आप क्या लिखेंगे आगे? Hash. Similarly, अगर आप इसको बाइनरी में लिखना चाहते हैं, LDM, फिर आप क्या लिखेंगे? B और फिर आप लिखेंगे 1 2 4 8 16 32 64 128, लेकिन इसके आगे भी हैश लगाएंगे आप। ऑलराइट, और अगर आप इसको लिखना चाहते हैं हेक्स में तो फिर भी आप हैश लगाएंगे। अब आपको पता है कि हेक्स का या हेक्सा का 5 हो या वो आपका डेनरी का 5 हो, तो आपको पता है कि 0 से लेके 9 तक तो दोनों बराबर ही होते हैं, तो ये चीज भी आपको जहन में रखनी पड़ेगी। ठीक है, सो माइंड इट। Anyways, if there is any question, please do ask it. So hash denotes a denary number value, B denotes binary number value, and ampersand or N denotes hexadecimal value. And this address can be an absolute or symbolic address. All right, so they are not going to use any base address. As I told you yesterday, that I have never seen any base or relative addressing used in the system. Okay, so now let's solve few tracing questions. With these commands, we would have to solve few questions in order to grasp the idea of all these commands. Otherwise, it will become hard for you. अब देखें, ये क्वेश्चन है हमारे पास असेंबली लैंग्वेज का। ठीक है, चाहिए एक पुराना क्वेश्चन है, तो हो सकता है किसी कमांड में आपको डिफरेंस भी नजर आए, बट दीज कमांड्स आर ऑलमोस्ट द सेम। अब अगर आप यहाँ पर गौर करें तो आपको ये इंस्ट्रक्शंस नजर आ रही हैं, और ये आपको डाटा नजर आ रहा है। ठीक है, आप इसको इस तरीके से आसानी से देख सकते हैं that these are instructions जहां पर आपके पास opcode है, and over here it's just the data. Okay, so that is how you can understand that these are instructions. Now let's start. The first instruction address is what? 100. First instruction address is 100, and this 100 says that LDI indirect. So it says that go to 150. This is indirect, and from 150 take the address of actual data, go to that address 200 and bring this 65 to accumulator. Get the idea? So this is indirect. Okay, so when we execute this LDI 150, we will go to 150, but at 150 this is 200, then we will go to 200 and we will bring the 65 to the accumulator. Done. Then we have got second instruction. Second instruction is basically out, and I told you that out is what? Out is whatever the number that is in the accumulator will be treated as the ASCII code, and related character will be shown over the screen. So what will be output? A. You may write this A in the same line, or you may write A in the next line. It's up to you. All right. So location 150, let's write it in the same line, A. So what is location 150 over here? 200. So accumulator is loaded with 65. That 65, when it will be output to the screen, we see what? A, and location 150 is 200. Then we go 102. 102 says LDD 150. So this is direct address. So what is present at 150? At 150 we have got 200. So this 200 will be loaded to the accumulator. This is direct addressing. Increase accumulator. I told you what increase does. It increases the value of the accumulator by 1. So this would become 201. Then it says that store it back to 150. Means whatever is in accumulator will be stored in the memory at the address given. So 150 will now be 201. Okay. And then JP100, this is JMP basically. Jump back to 100. So it does not want you to go to 106, rather it wants you to go back to 100. So we will again start executing 100. Okay, so 100 says that LDI 150. Now when we go to 150, yes, it is a loop bit, but this is never ending loop, honey. This is a loop, but it is never ending loop because it always makes you go back to 100. So there is no comparison. So it is unconditional loop, which is actually ever going on. तो ये वो नहीं है, condition इसमें नहीं लगी हुई है, इसलिए ये बस चलता रहेगा. ऐसे questions में basically what happens in such questions, exam में given होता है that how many times you have to execute it. So let's say let's execute it 3 times, 4 times. Okay, so we go back to 100. This says that LDI 150. So now this time 150 has got 201. So first we access 200. Now we will access what? 201. So what is that 201? 76. So this 76 will be loaded out. What is 76 in ASCII? Hold on. Let me find out. Actually 76 is L. So 76 is L. Okay, so 76 is L. All right. So it says that LDI 150, at 150 we have got 201. So we go to 201, we load this 76 to accumulator, then it says out. So out 76 equivalent is actually L, and then we go load 150. So load 150, 150 is actually now 201. And then it says that increase it. So this would become 202, and then store it to 150. So it will go back to 150. Now this 150 would have 202. Okay, and then it says go back to 100. So अब हम वापस 100 पे आ जाएंगे. $100 says that LDI 150. Now we go to 150, we find what? 202. Then we go, so at 150 we have got 202. At 202 you see it loads what? 65. Then it says that out. So this is again A. Then it says increase, load 150. So this time 202. Then it says increase it 203. Store it back to 150 location. So we stored it back to 150 location. Now we have got 203. and then it says that go back to 100. That is how it would go on. Okay? So get the idea. So this is the first trace that makes you aware of LDI use, out use, LDD, increase, store, jump, and end. So end never reached out, but now we know that how it actually works. All right. So let's solve another question. Now, let's see how it is working. So this is our program. In computer's main memory. From 97 to 100 we have got instruction, and from 101 to 102 we have got data. So instruction is at 97, it is LDD 101. So we know that how fetch decode execute cycle actually works. So from PC the content goes to MAR, from MAR it reaches out to RAM with address bus, and from that address bus over the data bus the content arrives in MDR. From MDR it goes to CIR. This is fetch, and then when it is executed, accumulator is filled with the data that is required. So 97 is the address in PC, that 97 goes to MAR, and then PC increases itself by 1, becomes 98, and then when address bus points to 97, LDD 101 arrives in MDR. Now from MDR it goes to CIR, so LDD 101. So this 101, at address 101, whatever the content is present, we can see that it is 2. So the 2 will be loaded in accumulator. All right, so PC becomes 97. From 97, MAR has 97, PC becomes 98. In MDR we have got what, LDD 101, and then it goes to CIR, that becomes LDD 101 as well. It is then executed and we got what, 2. Then this 98 goes to MAR, PC makes itself 99. At 98, what do we have? Add 102 means whatever the content of accumulator will be added with the content of 102, that is 9. Add 102. So add 102. What is at 102? 9. So this will be added to the content of accumulator. 9 plus 2, 11. Then 99 goes to MAR. PC makes itself 100. At 99, what do we have? Stored at 103. So whatever the content of accumulator will be stored at 103. Whatever the content of accumulator will be stored at 103 when this store 103 commands is executed. So store 103, when it reaches out to CIR, this 11 is basically saved at what? 103. Then it is 100. PC makes itself 101. At 100 we have got end, and then when we have got end, computer programs ended. All right, get the idea. Now every program instruction has got one more stage if that instruction has an address part, because that address requires to be fetched. So as soon as this LDD 101 reaches out to CIR, this 101 will be put in MAR ताकि उस 101 से हम 2 को fetch कर सके. So 101 will be placed in MAR. MAR will now point to the memory with this address. The content of this address 101 will arrive in MDR. And from MDR, it goes to accumulator. Okay, so that is how the whole thing works. All right, so this is proper fetch, decode, execute cycle working. Let's look at one more question. So we have got this program now. Okay, so the first instruction is at address 105. So this 105 will be loaded to PC 105. From PC it goes to MAR 105. PC increments itself by 1. This becomes 106. From MAR, when MAR points to 105, LDD 114 will arrive in MDR. From MDR it goes to CIR. So what is LDD 114? LDD 114 load the content of the address 114 directly to the accumulator. So what is at 114.2? So first this 114 will be placed in MAR. So MAR will now point to this address. From this address, content arrives in MDR, and from MDR it goes to accumulator. This is one instruction executed in 2 cycles. Now this 106 goes to MAR, PC makes itself 107, 106 we have got add 115. Add 115 will go to CIR. Then this 115 will be placed in MAR, and at 115 we have got 3. So 3 will be placed in MDR now, and this 3 will now be added to 2, so to have 5. So this is second instruction executed. All right, and then we have got 107 here, PC makes itself 108. At 107 we have got increase. So when increase reaches to CIR, CIR will simply increase the content of accumulator by 1. I told you that increase always increase the content of accumulator by 1. So now this increase does not have operand part. So I told you that whenever it is not referring to anything, it means that it is referring to accumulator. Increase can increase accumulator as well as index register. So if it is ACC written here, then it will be increased accumulator. If it is IX written here, then it is index register that will be increased. But if it is nothing written there, it means that accumulator is being increased. All right. So accumulator is increased. Now you can see that these 2 instructions are executed in 2 instruction cycles, but this instruction is executed in 1 instruction cycle. Reason being that this instruction over here is referring to a memory address, and that memory address is required to be fetched. But over here, this instruction is not referring to any memory address. Now this 108 arrives in MAR, PC makes itself 109, and it says that jump to 112. Now this is a new thing. You have to be very careful and you need to understand this. This new thing is, we know that we call our computer a sequential machine. That is why 105 becomes 106, 106 becomes 107, 107 becomes 108, 108 becomes 109. But computer does not, the programmer or this program does not want you to execute 109 anymore. What they want you to execute 112 now. To skip 9, 10, 11, you have to reach out to 112. And you can see that your program counter, the next instruction that will be executed is 109. What is the purpose of program counter? To keep the address of next instruction. So what computer will do, when jump instruction arrives and goes to CIR, CIR places this 112 in PC because it wants the next instruction to be 112, not 109. So this 109 will be updated. So this 112 will go to PC now. So the next instruction that will be executed will no more be 109, rather it will be 112. So when you make the jump command, mind it, keep it in your mind that when the jump command is executed, the address that is given is updated in PC, because that is the address of the next instruction now, not the one that PC made itself. Okay, so now PC has become 112. So as soon as this jump 112 is executed, this 112 is placed in PC. From PC, it goes to MAR, and PC makes itself 113 now. With this 109 is overwritten. It is no more there. 112 is there. 112 goes to MAR, PC makes itself 113. At 112, it is stored at 116, sorry. So it goes to store at 116. Now, this 116 is required to be placed in MAR. I told you that MAR is connected to address bus, and that address bus is always pointing out. If computer or the microprocessor requires to fetch in the data, it points out to memory location. If it wants to put the data back, write the data back to the memory from the accumulator, in that case it is again pointing out. Why it is pointing out? Because we need to tell the computer where to place the data. Why it is pointing out? Because we want to fetch the data from that location. So whether you are writing to the memory or reading from the memory, in both of the cases you are pointing out. So the way I told you that whatever the content that you want to require from the memory, you put the address of that content in the MAR, MDR receives the content. Similarly, if you want to put the content of accumulator back to memory, you do the same. What you do, you put the address in MAR and content of the accumulator in MDR, and it goes back. So similarly, what is the content of accumulator 6? Where you want to write it at location 116. So this 116 is actually right back to RAM. So this 116 is placed in MAR, and this 6 will go to MDR, and from here it will then copy to 116. Get the idea? So you would have to actually write these all things down. Sometimes they want you to write in theory. Sometimes they want you to trace it and trace it properly. And sometimes they want you to explain that what has happened. Okay. So this instruction is now executed. Then from 113, address of the next instruction, which was 113, arrives in MAR, becomes the address of current instruction. This PC will become 114. At 113, what do we have? We have end. So this is actually here, end. And then when end reaches out to CIR, the control is given back to the operating system. What does it mean? Control is given back to the operating system. It means that actually the program is ended. All right. Okay. Now let me show you a few of the resources that you want to access, and I want you to basically practice few of the questions. अब देखें, हमारी एक वेबसाइट है, इस वेबसाइट को आप एक्सेस करें. वेबसाइट का एड्रेस है zakonweb.com. सही है, ZAKONWEB, zakonweb.com. ऑलराइट, आप इसको एक्सेस करें. And in this website आपको यहाँ पर मिलेगा AS level. ठीक है, AS level. आप AS level पे जाएं. अच्छा, ये अभी जो है आपको, जो हम इस वक्त पढ़ रहे हैं, वो आपको मिलेगा 1.4 में, ठीक है, 1.4, 1.4.1, 1.4.2, 1.4.3, 1.4.4। तो जो अभी जो प्रैक्टिसेस हैं वो आपको किस में मिलेंगी, 1.4.4 असेंबली लैंग्वेज में, ठीक है। अब इसके नोट्स भी हैं, असाइनमेंट्स भी हैं, एफएक्यूज भी हैं, वीडियो लेक्चर्स भी हैं, पास्ट टॉपिकल्स भी हैं। तो आप पास्ट टॉपिकल्स को फिलहाल उठा लीजिए और इसके अंदर ये बहुत सारे क्वेश्चन हैं प्रैक्टिसेस के, आप इनको प्रैक्टिस कीजिए, ठीक है। ये सारे क्वेश्चंस आपके पास हैं, इनको आप प्रैक्टिस कीजिए। ऑलराइट, लेट मी टेल यू अगेन, तो वेबसाइट इज zakonweb.com और इसी तरीके से हमारे पास जो है